Hello everyone. So far we are discussing all the methodology and the data preparation technique and data management technique using SQL and Spark. So beside that, we gonna take another tangent from here, which is actually taking one step further. So once this data has been prepared, what we're going to do as part of our data and analytics job activities. And sometimes it's not part of the job, but it would be good because if we understand these techniques, it would really help us to improve the quality of the data. And guess what? What we are talking? We are talking about machine learning. So machine learning is not only help the business to identify the insights from the data, but it also helps the data engineering team to identify the hidden pattern or hidden anomalies within the data set, so they can fix those anomalies, or they can raise it with the business to get the feedback and improve the quality of the data. So never think of the machine learning and data science is only relevant towards the insights which the data scientists are producing. It's actually a mutual effort between the data analytics and the data engineering team. They work hand in hand to make sure that whatever they are producing is providing the full value to the business. That's why we're going to actually blend our data engineering course with some of the technique that I do believe can really help you, especially while you are preparing or while you are, doing the data preparation, data extraction, or we call it data munging, or there's another term, exploratory data analysis, EDA activities, feature engineering. So these are all collectively produce the right data for the model. And obviously, if you know the target model which is going to consume the data, that will certainly improve your work, or improve your techniques to prepare the data accordingly. So these are a couple of rationals behind recording these videos that which not only help you prepare yourself for the data science perspective, but also from the data engineering perspective as well, because eventually you need to prepare the data for the model. And like I always mention, the model itself is nothing, but it's more like an equation where you need to feed your data, and then whatever data you are feeding in it, it's going to actually produce the outcome based on that. So by saying it, let's quickly have a look at the machine learning introduction today. We're going to start with our first algorithm, which is linear regression, because that's the simplest one, and that's always a good starting point to start simple and then moves towards a comparatively complicated one. By saying it simple, it doesn't mean that it's less effective. Tell you the truth, most people, they are still using linear regression to predict the values till today. It's still a most popular algorithm within the data science community, just because of its simplicity. Obviously, it has a couple of challenges where you need to look at how you can improve the performance once we have millions, and I would say even close to billions of data points. How we going to actually make sure the linear regression is working fine on that. But these are the later cases which we're going to look later. So let's have a first look at the quick theory, so it will help you to understand the core concepts. Let me share my screen first. All right. So what we are going to do, we are going to now learn the machine learning and data science using Spark and SQL. Like I mentioned, Spark and SQL, they gonna stay here throughout your career path in the data analytics, which consist of the data engineering, machine learning, and data science. Now, machine learning is a broader concept, and data science, you can put it, it's a subfield of the machine learning, because machine learning is not only, handling the all the area which data science is handling, but the context is broader, because purely when it comes towards the data science, people think about, oh, someone needs the statistical skills or SQL skills, and Excel skills to prepare and run the data through statistical model to generate the outcome. And then obviously we need to run a couple of tests to validate the hypothesis, and then we can predict the probabilities based on the event. So that's all covered within the data science. But there's a broader aspect where we look at how the more advanced model or more advanced algorithm has been built, which sit under the machine learning umbrella. Like you can imagine, I think instead we use the differentiation, we use the integration up to some extent, where we have the categorical variables in different contexts. I'm not going to go into detail, but these are the areas when you want to move a little bit further or advance, you need to move away a little bit from the stat sides, and then you need to focus more on the mathematical side, which covers more likely under the machine learning area. And the biggest example you can see is the deep learning, which is based on the neural nets and how the information is flowing between neurons, and at the end we are producing, and then based on the information flow, based on the network of these neurons, the system will learn automatically and improve its outcome based on the data. So it's a big debate, like whether the both fields are similar or one is the subset of the other. But we try to cover both sides in this course. All right. So let's quickly have a look at the definition. So machine learning is using statistical techniques and sometimes advanced algorithm to either make prediction or learn hidden pattern within the data, and essentially replace rule-based system to make data-driven system more powerful. What does mean by data-driven system, and how it moves the system from rule-based to data-driven, we're going to see in a moment. And that's one of the biggest difference between using a system or building a system using a core logic, or feeding the data to actually let the system to learn the logic by itself. There are plenty of simple example we're going to see, and it will really help you to understand this concept. Just right now, just focus on these two things, that we are going to replace the rule-based logic with the data-driven logic, which is obviously the biggest charm of working in the machine learning and data science. So what's the data science? Data science is a collection of techniques used to extract value from data. It has become an essential tool for any organization that collects, store, and process data as part of its operation. So like I mentioned, in the data science, the core focus is purely about the data which any enterprise is collecting, and that covers the technique how we can extract the value. Keep in mind, right now, one of the biggest challenge that industry is facing, we are asking data scientists to extract the data. Unfortunately, that's not their job. Their job is to extract the value out of the data. So the extraction, preparation, and presentation of the data to the data science team, that's the job of the data engineering. However, taking that data and get the max value out of it, that's the data science area where data scientists shine, and they have their statistical techniques and all these algorithms they can apply to get the most value out of it. So we're gonna see both fields side by side in the upcoming videos. It will clarify all the differences and all the context of both sides. In data science, techniques rely on finding useful pattern, connection, and relationship within the data. Those hidden trends that if we don't have the data, we are unable to find out. And simple, if we are seeing that, okay, some of the customer who are leaving our services, they have some common pattern, like they behave in a particular way. So the data actually show you the that pattern in once apply data science technique. These people who are leaving the service, they form their own cluster, and you can imagine, based on the data attributes, we have multiple cluster, and based on these cluster we can identify the pattern. Okay, there's a bunch of customer, and some of them have already left the service, so we can ask our sales team or marketing team, or even customer retention teams, to work with these customers who we believe are subject to leave the service, right? So these are all covered under the umbrella of the data science domain. Okay, so let's start from the machine. Like I mentioned, we're gonna start with simple, and then we slowly make it advanced. And in the parallel, like you are already learning how you're gonna prepare the data. So you can see once your data has been prepared from the data engineering side, you can feed it into your model and get the max value of that data to your business, and that will complete the whole picture in front of you. And it's always better to see the full picture, because sometimes if we are so focused on one side of the picture, it might not help us to understand the full picture on a broader level. And obviously, after working some time in the data industry, you want to move forward or move up in your career. So understanding both aspects of the data side will really push your career and help you, to move fast in your career progress. So by saying it, coming back, we have four major categories of the machine learning models which are available in the market. One is supervised learning. The second one is unsupervised learning. Third one is semi-supervised learning, and fourth is reinforcement learning. We're gonna see all these techniques one by one, because every category contains some of the famous algorithm within them, and we're gonna actually run those algorithms, and we're gonna see how they are helping us to produce the true value out of our data, which we can feed it into our business strategy and achieve the business vision or goals. Okay, we'll start with the supervised learning. In supervised, like you can see, in supervised learning, our model has work on the supervision. Like we first feed the data, we supervise our algorithm to learn, and based on that learning, it start predicting, or it start recommending the information back to us. So it's not like it is doing everything by himself. We are feeding. So for example, we are feeding the data to our algorithm to learn how it's gonna actually predict. So for example, let me take an example that we have a disease recommendation system. Now that recommendation model that we have built, what it is doing, it is consuming the attributes which we are providing. For example, person medical history, and that history can have different type of attributes, like for example, patient past history, the disease patient has, all these that we can model in the patient management system. Based on that, we feed it, and then based on that we define, okay, if the person has these symptoms, then a person is probably subject to having that particular disease. So for example, if person has disease A, B, and C, we say that person is going to be person is going to have the disease, for example, X. So similar way, we feed multiple attributes, we feed this data set into our model, and then based on that, machine will learn. Now, once an unknown data set comes in, a row or record comes in, it will compare, and based on the existing data, it recommend or it predict whether the person is going to have that disease or not, right? So that's what is the concept of supervised learning, where we use the existing data to prepare our model, and then the model will recommend or predict the outcome for us. Another simple example, for example, you have the house data set, like you have the number of rooms, you have the number of baths, you have the lawn, and then you have the area of your house, and based on that you have the house value. So now you have bunch of houses that you have compiled them in a nice tabular format and feed it into your supervised learning model. After couple of weeks, you got a completely new house, and you want to predict the price. So what you're going to do, you will feed those attributes into your existing model, which is already built based on the existing data, because you have already supervised it. You have already instructed, okay, these are the attributes that you're going to actually consider once you recommend the price. So it's going to use the existing data to predict the price. Now here, remember, it's not going to be 100% accurate, right? So accuracy is another big question within the machine learning and data science. It's not the 1 and 0 kind of thing. It's going to be between 1 and 0. You're going to have a answer which is closer to the right answer, right? And the whole I would say efficiency is how closer your answer is going to be the actual figure, right? We're going to discuss all this concept later. All right. So we're going to start with regression. So regression, and even in regression, we're going to discuss with linear regression. So for example, we have a simple data set. We have the age and we have this salary. So regression is more like, where you can predict a value, a numerical value based on and other existing value, considering there's a linear relationship between these two value. Obviously, the value which we are looking, one of the value is going to be independent and one of the values going to be dependent. The value which is going to be dependent, we always predict or recommend that value using the linear regression. And obviously, once I say linear, there is going to be a relationship between these two dependent and independent variable, like they are either going to be increasing or they are going to be decreasing. What does it mean? That if we are, so for example, let's take the example of this data set. So by increasing the age, we have the relationship that the salary of the person is increasing, right? So the more age is going to be, the more salary person is going to get based on his experience and based on his efficiency in whatever domain he or she is working, right? So that's a very simple. So you can see if we draw that model, it's going to be like this. So you can see I have drawn this one, and you can see these points are all scattered along. Now, obviously, these points are not going to be in the straight line, right? Which is not possible. It's going to be closer to a straight line, but obviously there are going to be gaps. And if we try to draw a straight line, it's going to be like this, that some points are going to be over the line, some points are going to be closer to the line, and obviously some points are going to be far from the line. These are going to be more like outliers. But outliers are, we're going to discuss it later, right? But that's the whole point of, there's a linear relationship that where which is showing us as soon as the age of the person increase, his salary is going to be, or his earning is going to be increased as well. So that's the linear, and the technique which we would use to recommend or predict the unknown value using this relationship, we called it linear regression, and that is used for prediction for most of the numerical values, right? And why I initially mentioned that, in your data engineering area, sometimes, when you have a missing value, you need to recommend the value. So the linear regression really help you to look at the existing data, and then you can recommend the gaps in the data, and that will complete the data set, and it will improve the accuracy of your prediction once that data is going to fed into the actual machine learning model, right? So if you're gonna see, there are many advantages to apply this technique even during the ETL process, because that will simply improve the accuracy or quality of the data, which is going to be feed into the machine learning model later, and or we're gonna hand over to our data scientists, and they're gonna use that data to generate the outcome for the business. So how the linear regression work? Like I mentioned, now that's where we are now coming towards the mathematical part. Like I always mention, the machine learning and data scientist, it's all about the data, how you are going to prepare the data, how you are going to maintain the data, how you are going to feed the data into your model, right? Because the algorithm itself is already defined algorithm. It's more like, an existing black box where you need to plug in, and then it's going to do the work, and it's going to extract the outcome on the other side. The only thing, if you want to unfold that black box and you understand the math, you can unfold the black box. That's not a big issue. But most of the case, we don't need to worry about the black box. All we need to focus on feeding the right data, and once the information comes out, we can translate it to the business. So that's these are the two major areas where we need to put our focus on. Now, y is mx plus c. It's a very famous line equation. Like I mentioned, we normally draw the line which covers most of the data point. Obviously, it's not going to cover all the point. Otherwise, the line is going to not. It's not going to be straight. It's more like going to be a very irregular line, and we called it overfitting. Overfitting and underfitting we're gonna see later on once we discuss the challenges with the linear regression. But at the moment, just imagine that whenever we draw the line, some points lie on that line, some points are closer to the line, and some points are obviously far from the line, right? And whatever the distance between the line and the points is going to be, that will calculate the error or the accuracy of our model, right? Because if I just consider this one, which is the farthest away, and you can see this is the guy who is more like an exception guy. Like theoretically, we have people who has more age, so they are earning more. But this guy, he's 25 and he's earning 10 grand per month. So with these data points, they are more like exception, and exceptions are everywhere. In every data set, you're gonna see there are many exceptions which you need to consider. They are not going to be treated separately, but obviously they're going to impact on the accuracy of your outcome. Okay, so coming back to that equation, m is more like a slope of our line, and what the slope is, just ignore that. I'm going to explain it in a separate video where we're going to discuss the math of this of the linear regression. Right now, just imagine that slope is more like help us to calculate the difference between the 2 points, so we can identify the the difference of this point over the line. So that will multiply by x, and then we add the intercept, which is equal to the prediction. Now this is all very technical. I'm just not going to actually go into detail at this stage. Just keep in mind, x always is the independent variable. M is going to be slope of the line, and C is going to be y-intercept. If you don't understand, don't worry. I'm going to actually, there's a video which explain the math of the linear regression, and you will understand every part of it in that video. But now the question is, in here we only have one independent variable. So one independent variable, and the other one is uh, the dependent variable, which we are predicting as part of the linear regression. So how are we gonna build our equation if we have more than one independent variable? Because like I mentioned in the house example, if we want to predict the value of the house, we have the number of beds, we have the house area, we have the number of bathroom or washroom, and we have the front garden, or back garden, and all these independent variables, they're going to contribute into the dependent variable, which is equal to the price of the house, right? So in that case, obviously this equation is going to be extended and cater all these additional variables. So once we have the multiple input or independent variable, our equation extend, and B0, B1, B2, they are all coefficients. So coefficients are more like, it's more like the slope of each line, which is impacting on the value of our dependent variable. And obviously intercept is always going to be the same, which is going to be a constant. And I'm going to actually explain all these from the mathematical perspective in the mathematical explanation of linear regression video. Right now, just take my words, and then we will in the next video we're gonna see the math. If you are interested, if you are not interested, just keep it in your mind that in linear regression, what you're gonna do, we're gonna actually build the data set in a way where we have many variables, or we have one or two variables, and then we feed into our linear regression model, and it will return us the outcome, or which is more like normally linear model, they won't return the exact value because we feed the data set. What it return these b0, b1, b2, b3, which are obviously the slope, or you can say coefficients of our equation. So we can feed any data and we can calculate the y by ourselves, and obviously the intercept. So how it will do it, there's obviously an underneath math which is already been built. One thing you need to keep in mind, guys, this math has already been built, proved, and executed by many for a long time. So no question about the accuracy of that model. What we are more like interested, we need to prepare the data and feed in a way that it can provide us the best accuracy. Now, a lot of theory, and what we're gonna do now, we're gonna actually jump and we're gonna run our first machine learning demo, obviously using Spark and Databricks. So hopefully that video will help you to understand the core concept of machine learning and data science, and a very brief explanation of linear regression. Please put any comment or any suggestion if you have. Otherwise, I'm gonna see you in the next video. Thanks for watching.